Hello guys, today we are going to see a thermodynamic statistic numerical. So first we see a type of statistical. First is Maxwell, Boltzmann statistic. Second is Bose Einstein statistic, and third is Fermi direct statistic. We see a one by one. First we study a Maxwell, Boltzmann statistic. We also call this as the MB statistic. So first point is particle should be distinguishable that is A, B, C like this. Second is any number of particle occupy same energy level. Third point is we also call this Boltzmann Maxwell. So first how to calculate how to find the number of microstate if indistinguishable particle distributed in level E0, E1, E2, E3, so on till EI, and particle in each level are N0, N1, N2, N3 till Ni. Then the formula is the number of microstate W equal to n factorial upon n1 factorial, n2 factorial, n3 factorial like this, so on. So we write like this as a n factorial upon pi n ni factorial. The pi is multiplication. Is n1 factorial, n2 factorial, n3 factorial. So we write this as a n factorial pi ni factorial. Pi means ni n1 factorial into n2 factorial into n3. So this multiplication denoted by pi, and this is ni. I is 0 to I, 0, 1, 2, 3 till I. So solving some problem. Sixth, identical particle having occupation number 0, 1, 2, 3. Find it microstate, number of microstate. So we calculate as W equal to n factorial upon pi ni factorial. So here given a 1, 2, 3, 4 is n1. This is n0, n1, n2, n3, and this capital N is 6. So 6 factorial upon 0 factorial into 1 factorial into 2 factorial into 3 factorial. So we write this as a 6 into 5 into 4 into 3 factorial. 0 factorial is always 1, 1 factorial is 1, 2 factorial is 2 into 1, and this 3 factorial. 3 factorial cancel, is 2, we cut by this, we get 3, 3 4s are 12, 12 5s are 16. So we get a W equal to 60. If we want to calculate the entropy, so entropy is S. So the formula is K L W is K L W. We get W is equal to 60. So we write as a S K ln 60. Now next we see a if n distinguishable particle distribute level EI having degeneracy GI, and then apply the formula. Means that if n distinguishable particle distribute the level EI and having degeneracy GI, so we'll calculate the W equal to n factorial, and this is pi GI raised to Ni divided by Ni factorial. We solve some problem based on this one problem that the 4 distinguished particle distributed in energy level E1 and E2 having degeneracy 2 and 3 and 3 particle in E1 state and 1 particle in E2 state. So find the micro state. So we know the formula W equal to n factorial pi is a multiplication GI raised to Ni, this is Ni factorial. So this 4 value here, n equal to 4, and degeneracy of E1 is 2 and E2 is 3. So G1 is 2 and G2 is 3, and here this, for this n value is Ni value is this 3 for E1 means 3, and for this one particle is for A2 state. This Ni is for this is 1. So we write this as a 4 factorial 2 by 3 factorial this 3, this multiplication to this pi. So now this 3 raised to 1, now here 1 factorial. Now 4 factorial, this is 8, this is 3 into 2 into 1 multiplicative this 3, now this is 1. So this 3 cancel, this 2 ones are, this 2 fours are. Now this 4 into 3 into 2 into 1, this 4 factorial I have written this like this here 4. So now we get the answer this 4 4s are 16, 16 into 6, this is 96 we get. W equal to 96. So let's solve a more problem. If total energy and individual particle energy level gives them, then we apply the formula that W equal to n factorial upon this n1 factorial upon n2 factorial. This W equal to n factorial upon n1 factorial n2 factorial. So let's solve problem. This 4 identical particle distributed in 3 level having energy state 1, 2, 3 unit respectively, and total energy is 10 unit. So find the microset. So there are 4 identical particles in the 3 level of energy state. So 1, 2, 3, 2, 3, and the total energy is 10. So here 1, here 1, 2, 3. So here 3 into 3 plus this 1. So here we get 10, and another possibility is 2 here and 2 here. So this 3, 2, 1. 3 into 2 plus 2 into 2. This also is 10. So we have the formula that W equal to n factorial upon n1 factorial n2 factorial. So for this we calculate the n, capital N value is 4, and here n1 is 3 factorial and n2 is 1 factorial. So we get a 4 into 3 factorial upon 3 factorial. 3 factorial cancel. We get a 4. Now this is of 1, and another for calculating W2 is for this n factorial upon and 1 factorial and 2 factorial. So capital N value is 4, 4 factorial. Now n1 factorial is 3, 2 factorial here is 2, so 2 factorial and this is 2, 2 factorial. So now 4 into 3 into 2 factorial, 2 factorial into 2 into 1, 2 factorial cancel, this 2 ones are 2 twos are, here we get a 6. So W equal to W1 plus W2, we get a 4 plus 6, that is equal to W equal to 10. Now we move to a bosons. Next we see a Bose-Einstein statistics. So first point is particle should be indistinguishable in Maxwell. We have seen that there is a distinguishable, and in this Bose-Einstein statistic is indistinguishable. So remember this point, such like a. Second point is having a integral spin 0, plus 1, minus 1, plus 2, minus 2, so on like this. And the wave function is function R symmetry. Remember, this is important point. Wave function of symmetry with respect to nuclei, with respect to exchange nuclei or particle, we can say. Example, we can take a H2, D2, N2, He42. So here we calculate a number of microstate. The formula is W equal to n minus m minus 1 factorial, and this n factorial n minus 1 factorial. Sometimes we write a, instead of m we write a this g also, so this both are same. Somewhere you will see that this formula will be a n minus g minus 1 factorial n factorial g minus 1 factorial. This, so m is equal to g. So some, let's, there are 10 identical particle can be distributed in two energy level. Calculate microstate, number of microstate. So W equal to, so here this capital N value is 10 and this 2 state, so M value is 2. So we know the formula that n minus m minus 1 factorial upon n factorial upon n m minus 1 factorial. Substitute the value 10 minus 2 minus 1 factorial upon 10 factorial 2 minus 1 factorial. So we get here a 9 factorial upon 10 factorial, this is 1 factorial. So This is 9 factorial. So here we get to see this. Wait a second. Sorry. Here is a plus. So plus. So this 10 plus 2 is 12 minus 1 here 11 factorial. 11 factorial. Now the 10 is 2 minus 1 1 factorial. So 10 factorial. Now we can write this 11 into 10 factorial upon 10 factorial. 10 factorial 10 factorial cancel. We get a 11. So W equal to 11. Sorry for this. Here is a plus. The number of macrostate for a Bose-Einstein is n plus m minus 1 factorial and factorial m minus 1 factorial. So like this we solve one more problem. Let's see. If I take a m value is 3, n value 2. So calculate the macrostate, number of macrostate. The formula will be W equal to n plus m minus 1 factorial and factorial m minus 1 factorial. So we have a n value is 2. So 2 plus 3 minus 1 factorial. This 2 factorial. Multiply this 3 minus 1 factorial. So we get a this 5 minus 1 this 4 factorial, 2 factorial, and this is 2 factorial. So we write like this 4 into 3 into 2 factorial, and this 2 into 1 2 factorial. 2 factorial 2 factorial cancel. This 2 1s are 2 2s are 2 into 3 is 6. So we get a W equal to 6. Now let's solve. Now we move to a next third one is Fermi direct statistic. The first point in this is particle should be a indistinguishable like A. So in Bose-Einstein and Fermi direct statistic, the particle should be indistinguishable. Remember this. In Bose-Einstein and Fermi direct, the particle is indistinguishable. Now here, the second point is it is a half integral spin. In Fermi direct, it is a half integral spin plus minus 1 by 2 plus minus 3 by 2, and in Bose-Einstein we have seen that is a integral spin. Means there will be in Bose-Einstein there will be a 0 1 minus 1 2 minus 2, and in Fermi direct there will be a half integral spin plus minus 1 by 2 plus minus 3 by 2, and the wave function in Fermi direct is anti-symmetric, the exchange of particle. So for this how to calculate the number of macrostate? The formula is W equal to g factorial upon n factorial g minus n factorial. So let's solve a problem based on this. There is a 3 fermion occupy 4 energy level. So find the microstate. So n value is 4. Sorry, this energy level, the g value is 4 and this n value is 3. The formula is omega w equal to g factorial upon n factorial g minus n factorial. So g value is this 4 energy level, this is a g. So 4 factorial upon the 3 fermions means the n value is 3. 3 factorial, 4 minus 3 factorial. So we get a 4 into 3 factorial. This I write as a 4 factorial. We write a 4 into 3 factorial. This 3 factorial and 4 minus 1 is will be a 1 factorial. 1 factorial is 1. 3 factorial cancel. We get a answer is a w equal to a 4. We get a w equal to 4. So we can write this entropy equal to ln kW. We know that the w equal to 4 we got. So we can write a S equal to ln K4 entropy. Like this we will solve more problem tomorrow.